Gave up. No, thank you, sir. All right. Right. Hang on, the paint program's opening. Right. KJ, what information are we given here?
The radius.
The radius of what?
The radius of from the center of the Earth to the Sun of the car.
Right, so the radius there is
1.49 times 10 to the 8 kilometers.
okay.
And the angular speed 1.991 times 10 to the minus 7.
10 to the minus 7 yeah. Per second. What else have you told us that is?
Then question is the data to calculate the time taken in days for the Earth to complete the orbit of the Sun.
2 pi over omega in days. Well, we know what that is already. That's seconds. That's hours. 365, yeah. Right, what's next? Frequency? For real? Okay. In days, or you don't care? 2.74 times 10 to the minus 3 days to the minus 1. If you don't like that, and you shouldn't, we go back to seconds, yeah? Which will be, hold on. 31.7 nanohertz. Yeah? What's next? Speed?
Yes. At which is moving in this orbit.
V equals omega or. So 1.49. You said this is hard, KJ.
No, I said the speed part.
Alright, the speed is 29651, or if you want, that's in meters per second, or if you prefer, that's 29.6 kilometers per second. Yeah? What's next?
Use the information of the world to determine the mass of the Sun.
F equals m omega squared or F equals mv squared over or.
M equals V squared R over G.
Yeah, GM over R. V
Do you have to use the Newton's F equals GMM one, don't you? So Newton also said F equals GMM over R squared. So I suppose putting these two together?
Yes.
mv squared over R equals GMM over R. But we're looking for the mass of the Sun. Oh,
R squared.
R squared. So M equals V squared R over G. Is it? That's it?
Yes.
So the M equals V squared R over G. Okay, well that's why we got the V. What was the V? So what did I say it was?
2.96 times 10 to the 34.
The V?
So sorry.
What was the V? Just give me my V. 29.6 kilometers per second squared. What's the radius?
1.19 times 10 to the
And the G I know. So I got a mass, a big mass, 1.96 times 10 to the 30 kilograms. That's right? What part are we on now?
V part.
Alright, what's the V part looking for?
explain what is meant by the gravitational field at a point on the Earth's surface.
Right, do you remember what the gravitational field strength formula is?
G equals mf over
Gm over 4 squared, isn't it? What's the formula for it?
GM
Gm over r squared.
GM.
No. For the gravitational field strength. It's just Gm over r squared, isn't it? Okay. Hang on, the formula book's right here.
GR square over G.
Ah.
Yes.
Yes, what?
GM over R squared.
Continuing. Right, so what is the definition of field strength here?
The amount
No,
of
don't. Oh, you wrote it down yourself and didn't copy it.
the amount of gravitational force on the Earth's surface.
Yeah, well, it's the gravitational field strength is the force due to gravity per unit mass, and in this case, on the surface of the Earth. And in fact, we know the number here. What is it? It's 9.81 newtons per kilogram. Right, what's the second part?
Mean density of Earth.
Say again?
Mean density of Earth.
No. This was calculating the mass of Earth.
Yeah, that would make the next part easier.
Yes.
So we want the mass of the Earth. Okay.
Radius of the Earth is 6.37 times.
Well, we know that G equals Gm over r squared. So m would equal G r squared over G. Now, do we know the G?
Yes.
We do. And what's the radius of the Earth, please?
6.37 times 10 to the power 6.
And that's the radius, not the diameter, yes?
Yes.
So when you plug all those numbers in, you get 5.97 times 10 to the 24 kilograms.
Yes.
And Taki, you said the next part is the density, is it?
Yes.
And the formula for volume?
Over 3 pi r cubed.
So that's 4 over 3. Pi, and what's the radius again, please, KJ?
6.37 times 10 to the power 6.
So I got a density of 5,512 kilograms per meter cubed. Is that right or wrong?
Right.
It is correct. Now, are we on to the C part? Yeah? So what is so hard about the C part here? In a simple model of hydrogen, the electrons in the ground state in an orbit of 5.3 times 10 to the minus 11. Determine the force between the nucleus. What's kinetic energy? Okay, that is interesting, K to the J. Right, so it's a hydrogen atom.
Yes.
So what's at the center?
The
Proton. And out here? The electron. And the distance here?
5.3 times 10 to the minus 11.
And you want the force. So just use your buddy Coulomb, K Q1 Q2 over r squared. You know the charge is a proton and the charge is an electron. And the K you have as well, it's in the formula book. It's, I don't remember, 8.99 times 10 to something, isn't it? Look, here's the K here at the start. There it is there.
That's where the negative.
8.99 times 10 to the power of 9 times constant 23 times constant 23, and the distance between them, KJ?
5.3 times 10 to the minus 11.
So the answer I got when I put in my numbers is 8.22 times 10 to the minus 8 newtons. No?
8.19 times 10 to the minus.
Mine's more accurate because I use my calculator constants. I got 82.2 nanonewtons. What's their answer?
8.19 times 10 power minus
Wait, you know what? You know what? What did it get?
8.19
Yeah.
times 10 to the minus 8.
Good. The slight difference is mine uses the full constant value on the calculator. What's wrong with you?
That's the question.
Lol. Huh?
What?
That's why it's €200. Right, what's the next part?
kinetic energy of electron.
Kinetic energy of the electron. Well, what's the form for kinetic energy?
Half mv squared.
So what's the thing you don't know here? The V. Yeah? Now, you have this formula. KJ, look. You want the kinetic energy, don't you?
Mm-hmm.
Now, you have a formula F equals mv squared over R.
Mm-hmm.
So what does FR equal?
MV squared.
So does a half FR equal?
CV.
A half mv squared. So you can replace this formula with this formula, a half FR, because you know the F and the R. I still have the F on my calculator. Divide by 2 and multiply by the radius. What's the radius?
5.3
What is it?
5.3 times 10 power minus 11
So I got the kinetic energy. Is it in joules or electron volts they want?
joule
2.18 times 10 to the minus 18 joules.
per
Yeah. You said it was hard.
At the time.
Time to work.
If you have 16 to the factor, no, 8 to the factor.
I don't actually. I've been doing the maths for 8 years, the physics 3 years.
Okay.
I'm still learning. Every day is something new. Right, that's the end of that one, isn't it?
Yes.